Here we're going to look at try it number 2 from section 2.3. The graph shows the function y equals x squared minus 9x plus 20. So we're going to take this x squared minus 9x plus 20, and they want us to identify the zeros of the functions. How do the zeros relate to the factors? So if we're trying to factor this one, factors of 20 that have a sum of negative 9. So there's a lot of factors here, but let's say 1 and 20, 2 and 10, 3 doesn't work, 4 and 5. Since my sum is going to be negative, my factor positive, all of my factors are going to be negative. And the group that works would be negative 4, negative 5. So this would become x minus 4, x minus 5 in factored form. So now the question, how do identify the zeros of the function? Well, looking at this graph, I have 4, 0 here, and I have 5, 0. All right, we want to know how those zeros relate to the factors. Well, like in the previous video, if I take my factored form and in place of x, I write my zeros, which I pulled from the graph. So if I take this 4 and plug it in as my x, or if I use the 5, when I simplify this, I'm going to wind up with a y value of 0 for both cases. And that y value of 0 is the y value for my zeros of my graph, where it crosses the x-axis. So what we're looking at here is that the zeros, when they're plugged into your factored form, will give you the y values of zeros. All right, so again, what we're going to wind up finding, and you can see it on the bottom of the screen here, we're going to use something called the zero product property, and that's going to show us how we can use factoring to solve for the zeros without having the graph.